Hello everyone, this is going to be the second video that we're going to discuss from the last video. I'm going to discuss today a little bit on limiting and excess reactant, ionic and net ionic equation, and then solubility guidelines. So please bear with me. So we'll have limiting and excess reactant. Example. The next one will be discussed ionic and net ionic equations, and my last topic of this video will be solubility guideline. So I'm going to pick one example. We're going to have the following reaction. The reaction is when sodium phosphate aqueous react with barium nitrate. It's also aqueous. The products are barium phosphate, which is a precipitate. So I put S. S refers to that it's solid, plus 6 moles of sodium nitrate, aqueous. By the way, type of reaction like this nature is called a metathesis reaction. Metathesis, or in some literature you can see that it's called a displacement reaction. More technically, we can say that a precipitation reaction. Well, the reason why we need to say this is a precipitation reaction, as you see here, there is a solid substance is formed in one of the products. So barium phosphate is a solid. So it's called a precipitation reaction. Now, within this reaction, I'm going to show you the example of limiting and excess reactant, example of ionic and net ionic equation, and a solubility guideline at the same time. So we can do 3 examples at one time. Okay, so let's pick limiting and excess reactants first. Suppose we have this solution containing 7.5 grams of sodium phosphate react with let's say react with 6.9 grams of barium nitrates. Okay, these are the given values. This will be given barium nitrate. So we have 7.5 grams of sodium phosphate react with 6.9 grams of barium nitrate. So the question is, how many grams of barium phosphate can be formed? Okay, that's one question that we're going to address. So that way we can easily see the privilege of limiting and excess reactant. In order to answer this question, the first thing that we need to do is to find out which one is your limiting reactant. So the first thing that we need to do is make sure that the equation is balanced. You can see here that this equation is balanced. You have 6 sodium here. You will have 6 sodium on the product side. You will have 2 of the phosphate. You have 2 phosphate here. 3 barium and 3 barium, 2 nitrate and 6 nitrate on the reactant side, 6 nitrate on the product side. So that's very important that the equation is balanced. So now we're going to compare a mass of the reactants. The molar mass of sodium phosphate will be compared with the mass of barium nitrate. That way this will help us to determine which one would be our limiting reactant. So let's calculate the molar mass of sodium phosphate. The molar mass of sodium phosphate would be the mass of sodium times 3, which is going to be 3 times 23. Phosphorus would be 1 times 31, and oxygen will be 4 times 16, and that will give you sodium phosphate give you about 164, but we have to multiply by 2. 164 multiplied by 2, because we have 2 formula unit of sodium phosphate, so that would give us about 328 grams. So 328 grams of sodium phosphate react with, let's see, barium nitrate. The molar mass of barium nitrate would be the mass of barium, which is 137, and the mass of nitrogen would be 14, but 14 times 2 would be 28, and the mass of oxygen is 16. 16 times 6 would be 3 times 3 is 6 times 16, it would be 96. Okay, so it's going to be 137 plus 28 plus 96 is going to be 261 grams of barium nitrate. We have barium nitrate here. Okay, so let's clean up this, and then I'm going to go to the next slide. So we're going to continue from where we stop here. Remember that the equations that we had was 2 moles of sodium phosphate react with 3 moles of barium nitrate, provided as barium phosphate, and 6 moles of sodium nitrate. Now the question was that we have 7.5 grams of sodium phosphate given, reacted with 6.9 grams of barium nitrate, and we wanted to know how much barium phosphate is formed. So in order to find this answer, we need to know what is our limiting reactant. Okay, that's the first and the primary issue, is to find out our limiting reactant. So in the previous slides we saw that the molar mass of sodium phosphate was 328 grams of sodium phosphate react with 261 grams of barium nitrate. That was from the equation here. Okay, the numbers are coming from the equation here. So if I have 7.50 grams of sodium phosphate, how many grams of barium nitrate would I get? So I use a crisscross system, might be easier. So what I do is I'm going to multiply 7.50 by 261 divided by 328. So 7.5 times 261 divided by 328. Let's see what do we get. 7.5 times 261 divided by 328. That will be, I'm going to use my calculator. I'll give you is 5.96 grams of barium nitrate. 5.96 grams of barium nitrate. Now I'm going to compare this value, 5.96 grams of barium nitrate, okay, with the given value, which is 6.9 grams of barium nitrate. So we're going to see that for 7.5 grams of sodium phosphate, you basically need 5.96 grams of barium nitrate. But when we do the calculation, when we do the calculation, we got 5.96, but what was given to us was 6.9 grams of barium nitrate. It's a little bit over what we needed. So in this case, barium nitrate is going to be the excess reactant. Okay, the excess reactant. The actual value for 7.50 grams of sodium phosphate, we need only 5.96, but what was given to us was 6.9 gram. So this is going to be your ER. I use ER, it refers to excess reactant. So in that case, sodium phosphate is our limiting reactant. Okay, so now we can able to solve this problem, because once we know the limiting reactant, we can tell the amount of products that's formed. So let's see here. Once you know the limiting reactant, we can tell how many products that we get. So we can start from the point that you can say that, well, 700. We're going to calculate the molar mass of barium phosphate. We can say that 328 grams of sodium phosphate provides us 1 mole of barium phosphate. What's 1 mole of barium phosphate? 1 mole of barium phosphate. Okay, the barium phosphate is 506. Okay, barium phosphate. So the way how you calculate barium phosphate is 3 times 137, which is the molar mass of barium, plus 1 times 31, that's the molar mass of phosphorus, and 4 times 16. So that will give you 506 gram. So 328 grams sodium phosphate gives you 506 grams of barium phosphate. So if you have 7.50 grams of sodium phosphate, how many grams of barium phosphate you get? Okay, so we're going to continue this. We're going to continue. I don't have any space here. I'm going to continue here. So remember that we have 328 grams of sodium phosphate gives us 506 grams of barium phosphate. So 7.5 grams of sodium phosphate will provide us X grams of barium phosphate. So let's see. Okay, so now so now I have a space to write this down. So the equation is 320. Okay, here 328 grams of sodium phosphate provides us 506 grams of barium phosphate. And if we have 7.50 grams of sodium phosphate, how many grams of barium phosphate we get? So the answer can be calculated as we use a crisscross system. So we multiply 7.50 gram by 506 gram divided by 320. So what do we get? 7.5 times 506 divided by 320, we get 11.8 grams of barium phosphate will be formed. So the answer, the final answer would be 11.8 grams of barium phosphate will be formed, will be produced, in other words. So the bottom line is here, when you have a reaction like this nature, if you have two reactants are given, you have to determine which one would be your limiting reactant and which one would be your excess reactant. That way it would have been much easier to find how much product you get. Now this is about limiting and excess reactant. If you have questions regarding with limiting and excess reactant, I'll be happy to answer your questions. Please send me a comment, your feedback or your suggestion on a video tab, and I'll be happy to reply your answers. Now the next point is we're going to discuss about ionic and net ionic equation. So let's go back with the reaction. It's the same reaction. We're going to write sodium phosphate aqueous 3 moles of barium nitrate, which is aqueous, gives us or provides us barium phosphate, which is solid, plus sodium nitrate, which is aqueous. So in this case, what we have to do is we can rewrite this equation in the form of ionic equation. So when we write this equation in the form of ionic, we can say that whenever you see aqueous, right, they can be dissociated into ions. So you will have 6 moles of sodium ion, you have 2 moles of phosphate ions, 3 moles of barium ions, 2 moles of nitrate ions, and on the product side you will have barium phosphate. We're not going to be dissociated this because it's a solid, it is a precipitation reaction, and the sodium nitrate will be dissociated into sodium ion and nitrate ion. Now when we write equations like this, we call it complete ionic equation. It's called a complete ionic equation.